Rick, how's it going? It's time to have some more fun in the shop. I've got some parts from Savitsky Custom Classics, which consist of some real trick upper control arms, some real cool ball joints, and I've also borrowed my friend's alignment tool. And what I want to do today is look at my existing system, stock parts, and measure the camber change as the suspension cycles through the range of travel. And then put the new parts on, repeat that same test, go back and compare notes. So with that being said, let's go ahead and check out some parts. Okay, here's the parts. We'll begin with the ball joint. This thing is really high quality, like I said before. It's fully machined. It's got polyurethane boot. There's a zircon. It's just a quality piece. Here's the upper control arm. And again, this has the upgraded adjuster sleeves, so you can adjust camber and caster very easily compared to the original where you put shims in here. It's got zircons. There's a connection. It looks to be TIG welded, very high quality. I bought this with the ball joint already installed. It saves me some time. And the installation, there's a right and left hand. And basically this is going to be the driver's side, or I guess left hand. But you want to have the threaded portion facing forward. Over here we have the fast track alignment device. Again, it's my friend Jeff's. It's got bubble gauge that you can adjust to measure all the angles. I'm going to be putting these parts on that are going to grab my rotor. And here's the directions, and it looks like a mouse chewed them up. Jeff's got a problem with these damn mice in the garage, and he can't get rid of them. So I'll have to go online and find this document and print it out. But that's how I'm going to do it. Let's go ahead and check out the car. Okay, here we go. I'm going to start taking off some components to get the spring out of there. And I had this apart about a year ago, so these bolts were all easy to get off. I didn't put much tension on the upper and lower ball joints with tie rods, so I'm just going to tap them out with a lead hammer and then lower this A-arm down and take out that spring. Okay, I've got the rear spring out. I reassembled the suspension. I bolted on a rotor, and then I bolted on this alignment fixture from Fast Track. I've got this gauge zeroed out. The bubble's right at 0, so I'm going to start moving this thing up and down here and see what the camber angle variation is. Okay, here is the angle breakdown. So what I've got here is the distance I measured as a reference, and this is at full droop, and I set the angle device at 0. If I swing this all the way up to full compression, it's almost a 7-inch spread, but the angle goes from 0 up to a positive 2 3/8 degrees of camber, but it maxes out around here. So, you know, most cars don't drive at full droop unless you're a low rider or something. So let's say that you had a 24-inch was your ride height. So if this is your baseline, I make this 0, and I compress the suspension. I'm only getting a 1-degree camber change, and it's going in the right directions. Basically, it's a 1-degree change, which doesn't look that bad. Now, when you drop it down, it gets pretty sloppy here. It's getting down to -2 3/8. So, but if you're right around this range, I mean, I thought it'd be a lot worse than this. So let me go ahead and change some parts around and compare it again. Okay, comparison. Old ball joint, new ball joint. For those that don't know what a tall ball joint is, here is your lesson. I have scribed a line on each one of these studs that represents where the taper starts. That tapers where the diameter gets smaller. And this is what seats into the spindle. Notice how the tall ball joint has a lot higher spacing as reference to this mounting flange surface right here. So this tall ball joint has the same effect kind of as a lowering spindle. It places the wheels a little bit higher off the control arm and lowers the car. But what I'm looking for with these tall ball joints is the angle between the control arms, upper and lower, which I'll do a drawing about later. But anyways, here's your comparison. So the instructions tell me that I have to remove part of this ear to match this one for clearance, which I can do, but I'm going to go a step further and also add some additional welds because there's no bead on the inside of these, so I'm going to go ahead and do that. Okay, I've got all the new equipment in position, bolted down. I put the camber right at 0, kind of close to the original setup, but the caster on this thing is definitely probably 3 degrees more positive. But I just cycled this thing up and down here, and I can tell that this has got a lot more of a camber change, which I think is desirable. So let me get some numbers here, we can compare it. Okay, here are the numbers, and the numbers look pretty good for this new system. I normalized the camber angle and positioned it so that the camber angle was 0 at 24-inch ride height, so I can compare apples to apples. But notice that the original system, when I went to full compression, was giving me 1 degree negative camber, which is where you want it to go. But the new system goes almost 2 degrees further. So when I'm taking a turn and the car leans to one side, the tire taking the brunt of the traction should be near vertical and giving me a really good contact patch. Also note that when the suspension drops to full droop, there's also a difference. The original system at full droop went 2 3/8 negative camber, and the new one went positive 3/4. So again, when that car rocks to the one side when you're turning sharp, this tire is going to be square to the ground. Well, also, the inboard tire, which is going to be where the car is lifting up, this angle is also going to probably try to drive towards a more vertical contact patch. So this thing is going to have benefit on both ends of the car, right and left side. So From these numbers, I would say that these control arms and how they're aligned is definitely going to improve the handling of my car.